Hi, in this lesson we're going to look at percentages. We're going to cover most, I'm afraid not all, of the things you need to know for GCSEs. I'm going to focus mainly on the basic skills right now. So first skill we'll look at is percentage multipliers. So that's basically a number you type into a calculator to solve pretty much all percentage questions. So starting with the basic question, how would you find 44% of 230? You would have to convert this number into a decimal. Key thing to remember is that all percentages just means something out of 100. So 44% means 44 out of 100. Another key thing in maths is whenever you see the word of, it basically means times. So we can basically rewrite this problem as 44 over 100 times 230. The next step is we can just write this as a single decimal. 44 over 100 is just 0.44 times 230. And that is what you type into your calculator to solve this question. And this thing here, this 0.44, that's what we call the percentage multiplier. That was the important number we have to type in to find 44%. So the question instead asked, what would multiply number by to find 44%? That would be 0.44. So try a few of those. If you wanted to find 17% of a number, you would multiply by 0.17 because that is 17 over 100. If you wanted to find 4%, we have to do 4 over 100, and as a decimal, that is 0.04. We can go into decimals, of course. If you want 17.5%, that would be 17.5 over 100. And also, we know 17% is 0.17, so 17.5% will be 0.175. If you wanted 3.25%, well, we know 3% would be 0.03, so 3.25% will be 0.0325. Okay, next we have increases and decreases. So whenever you increase or decrease, you always want to start from 100%. So what that means is, for this question, we're starting with 213. So we start with our full amount, and then we're going to add on another 17%. If we are starting with our full amount, we are starting with 100%. We then want to add on another 17%. So we now want a total of 117%. The 100% we started with, and this extra 17% we're now adding on. We then do the same trick. Percent means divided by 100, so as a decimal, this will be 1.17. So if you want to increase 213 by 17%, you would do 213 times 1.17, or of course the other way around, where it's 1.17 times 213. And like we saw before, this part here, this 1.17, that is the multiplier you need to increase any number by 17%. So again, let's just see a couple of those. So if I want to decrease 47 by 3%, we follow the exact same idea. We're starting at 100% because that's my full value, and we're decreasing 3%. So that means we only have 97% left. So to decrease something by 3%, that's the same as finding 97% of it, because we have lost 3%. So you would do 47 times 0.97. And then the question, of course, could ask, what was the percentage multiplier to increase or decrease by a certain amount? So to increase by 38%, you would times by 1.38, which you want a total of 138%. If we want to decrease by an amount, we have to take it away from 100. So we do 100 minus 16, because we're decreasing now. That's what the decrease means. We now want 84%, so we'd have to times by 0.84. That would be your percentage multiplier. To increase by 83%, we start at 100, we're now increasing, so we're adding on. We now want a total of 183%, so that would be 1.83. Okay, and the same idea can work no matter what the number is. So decreasing by 94%, we want to take off 94%, means we're left with 6%, so we'd have to multiply by 0.06. Okay. A couple typical questions you might see will be something like this. So a computer typically costs £550 and it's 15% off. So you would do 550 times by that multiplier we just worked out. If it's 15% off, that means we have lost 15%. We start at 100, we take off 15%, that gives us 85% left. So therefore, we'll multiply by 0.85. We can do the same idea of an increase. So here, we're told a week shopping cost this in 2019. Now in 2020, it's increased by 4%. So our original amount was 88.54. To increase by 4%, we do 100 plus 4, which gives us 1.04. We can work that out. And again, in this question, it wants it to the nearest pence, which means the nearest 2 decimal places. So we have 92.08 because we round down in this question. Okay, next we have working out percentage change. This works for increase or decrease, and the best way to do it that I've seen is just use this formula. So we want new over old times 100 minus 100. So showing that in action, we have this question. The price of a bag of crisps increases from 46 to 53p. We then have to work out the percentage change or increase in this case. So the new price is 53 pence. The old price is 46 pence. Times by 100 minus 100. And all you need to do is go to your calculator and type that straight in. So get the fraction it, and I just want to look the exact same as I have written down there. So 53 over 46 times 100 minus 100. That gives us, as a decimal, 15.2%. It wants just nearest percent, so that would give us 15%. When you round to the nearest whole number. We do the same kind of question. So here the cost of a PlayStation is reduced from $399 to $349, and we again going to work out the percentage change, although in this case it will be a decrease. So we use the exact same formula. New price over the old price. Here the new price is the $349, and then we times by and minus by 100. We go back to our calculator, and we're going to type that in. Again, making sure it looks exactly the same as I've written down on paper. For this question, because it's a decrease, we're going to find out we get a negative answer. So here I've got minus 12.5. Because it's a minus, all that's telling you is it was a decrease. Okay, so there's nothing, anything's broken, but if the answer is positive, you've increased. If the answer is negative, you have decreased. So here we have decreased by 12.5%. Okay, and again in this question it wanted the nearest tenth percent, which is why I included the 0.5. Next skill is compound interest. So just explaining the basic idea really quickly. So if you start with £100 and if you get 10% interest on it, that means after 1 year you will have £110. Okay. Now for the second year we get another 10% interest. However, that 10% is off my £110 altogether. So now that would give you £121. And that is the amount it had after 2 years. The key idea with compound interest is you basically get interest on your interest. So because after the first year we had an extra £10, that means we then got more interest because we had more amount in our bank accounts. Okay, let's see the idea, and we'll get the formula that we're going to use for this. So another bank pays 5% interest. So if they invested £300, how much would they get after 3 years? So to increase by 5%, I would have to times by 1.05. I'll then work that out, and then I have to increase by 5% again. So I have to times by another 1.05. And then, because it's 3 years, I need another times by 1.05. And that's it. That's what you can type in to work it all out. There is a shortcut. We can just use indices here. So it's going to be 300 times by 1.05, and because there are 3 of them, it's going to be that to the power of 3. And that gives our formula that we can use for compound interest. So the initial amount times by the percentage increase to the power of n, where n is just a number of years. So here, each year a savings account pays 3% interest. How much would an investment of £2,000 be worth after 20 years? So my initial amount is £2,000. I then want to times it by the percentage increase. So if we're increasing by 3%, our multiplier is 1.03. So it's times 1.03, and then it's that to the power of the number of years, which is 20. And that's it. That's all you need to do. You can then just reach for a calculator and type that all in. So 2,000 times 1.03 all to the power of 20, which gives you £3,612.22. Okay, and that exact same idea works when we have a decrease. So each year a car depreciates or decreases by 10%. So again, we do 100 minus 10%. That means you have 90% left, so we're going to be timesing by 0.9. So the car is worth £20,000 when new. That is my initial amount, so £20,000. We then times it by the percentage increase, or I should say percentage change. In this case it's 0.9 because it's a decrease. And then to the power of the number of years, and here it's 8 years. And again, same thing, throw that straight into your calculator and that will do the rest of the hard work for you. Okay, we have questions where it's a bit not quite the same setup. So here, George invested £6,000. Each year his investment increases by 12%, so it times by 1.12. However, here we don't know how many years they're going to be. Okay, all we're told is after how many years will he first have over £10,000. Best we can do here is just guess. Okay, so I'm going to guess 3 years. I'm going to type in what will that work out. So we have 6,000 times 1.12 to the power of 3. That gives me 8429. Let's write that down. However, that's way too small. So let's try the same thing, however this time to the power of 4. So we go back to my calculator. Just need to delete the 3, place it with a 4. I've now got just under £10,000. So 9441. Keep going. We do the exact same thing. So let's copy this across, but now to the power of 5. And we type that in. And there we go. We have over £10,000. So that was 10,574. And for an exam question, this is absolutely fine if you're working out. You then have to give an answer after how many years. It was 5 years was when I first had over £10,000. Okay, I think it's the last thing to do, I certainly hope it is, and that is reverse percentages. So we can kind of see it here. So for this example, we have £120 and we want to find 60% of that. And we've just seen that, we would do 160 times 0.6 because that is 60% as a multiplier. We can then show the exact opposite problem. We could say, well, if we know 60% is 120, how could we work out the full amount? Okay, this you're basically working backwards, hence the name reverse percentages. So what's happened here is I had some amount, let's call it A. Let's say A is my total amount, and I found 60% of it. So I did A times 0.6, and that gave me my answer, which we were told is £120. What I want to do, I then want to work backwards to work out what my full amount is, what my A is going to be. We've seen in maths when we're solving equations that the opposite of timesing is dividing. So that means A is going to be 120 divided by or over 0.6. So what I'm doing here, I'm basically doing the opposite of finding 60% to work out my original number. We can then work it out on a calculator. So 120 divided by 0.6 gives us 200. So therefore the original amount was £200. Okay, slightly harder idea. Let's see it again. So 45% of a number is 27. We want the original number. So if I took 45% of a number, that means I had some number, again I'll call it A, and to find 45% I must have timesed it by 0.45. Again I did that, and then I got the answer of 27. Now I want to undo this, I want to work backwards. So to undo timesing by 0.45, we need to divide by 0.45. And then same as before, you just ask your calculator, what is that answer going to be? In this case it's 60, which means 60 was the original number, because 45% of 60 was 27. We're going to look at the same idea when we increase or decrease a number. So here, a number is increased by 32%. That means at some point, we must have times it by 1.32. So we need to undo that. The opposite of times by 1.32 is going to be to divide by 1.32. So we do 369.6 divided by 1.32. And I'll say here, basically, these questions are always designed so that you're always going to get a nice answer. Okay, it's very rare you don't get like a nice whole number. So here we get the exact number of 280, which is a really good sign that we're on the right tracks. And of course, we can do the same idea when we're decreasing a number. So here, a number is decreased by 13%. So if we've lost 13%, that means we are left with 87%. So we must have times by 0.87. We then want to undo that. So we take our number, the opposite of times by 0.87 is going to be to divide by 0.87, and then we just type it into our calculator. Again here, because we've decreased a number, we're going to expect to get a bigger number than 382.8. This case we do, and it is 440. Again, a nice whole number. Okay, just go for a couple of super quick examples. So here, prices are reduced by 15%. So we'd normally times by 0.85 to reduce by 15%. We're given the sale price, £102. To work out the normal price, you would do 102 divided by 0.85. So this method, this reverse percentages, only works if we're undoing something or working out the normal, the old, or the original price. Here we have the exact same setup. Price is reduced by 17%. That means we'd normally times by 0.83. However, we want the original price, so we do 207.50 divided by 0.83. Okay. Just quickly, we can merge those two topics together to look at compound interest reverse percentage problem. This isn't as scary as it looks. There's not a huge amount to this. So, Rimmer invests an amount of money in his bank, offering 3% per interest for 4 years. So, combining those two things together, you would normally times by 1.03, because it's 3% interest, to the power of 4, because it was 4 years. He did that with some amount, we don't know how much, but we know he then ended up with this amount here, £2,701.22. And then it's the exact same idea. The opposite of timesing by this thing is going to be dividing by this thing. So the original amount is going to be 2701.22 divided by 1.03 to the 4. Let's type that in and see what that gives us. So again, I said they should always give fairly nice whole numbers. Occasionally, if you're doing compound reverse interest, you might get like a really weird rounding error. So like you might end up with something like 0.99999. Let's see what we get. Yeah, here we got exactly that. So we got £2,399.9989. So for all these questions, you always want to round it to the nearest pence, and this to the nearest pence is exactly £2,400. Okay, and that's what I need to go through for this lesson. Hope you found that useful, and good luck.